Imagine turning on your Linux PC tomorrow and realizing that everything feels faster, cleaner, safer, and more powerful without installing a single new application. No flashy desktop overhaul, no dramatic hardware upgrade, no expensive SD swap. Just one hidden feature that has been sitting quietly inside your system this entire time. A feature so powerful that once you start using it, you'll wonder how you ever lived without it. And the crazy part? Most Linux users, even experienced ones, either ignore it or never truly unlock its potential. Today we're talking about something that can completely transform how you use your computer. Btrfs snapshots combined with system rollback. This is the hidden Linux superpower that can change your PC forever. Let's start with a simple question. Have you ever updated your system and something broke? Maybe your desktop environment refused to load. Maybe your graphics drivers stopped working. Maybe a kernel update caused boot failure. If you've used Linux long enough, you've probably felt that moment of panic. Your heart drops. You're thinking about crude environments, live USBs, manual package downgrades, or even a full reinstall. Now imagine this instead. You reboot your system, select a previous snapshot from your boot menu, and within seconds your system is exactly as it was yesterday. No data loss, no stress, no complicated recovery steps, just time travel. That's the power of file system snapshots, specifically when using Btrfs. Btrfs, short for B-tree file system, is a modern Linux file system designed with advanced features built directly into its core. Unlike older file systems such as X4, Btrfs doesn't just store files. It tracks changes at a structural level. Every time data changes, it doesn't overwrite blocks in place. Instead, it writes new data to new blocks and updates metadata pointers. This copy-on-write behavior is the secret sauce. Because data isn't overwritten directly, the system can preserve a complete record of what existed at any given moment in time. Now here's where it gets interesting. A snapshot in Btrfs is not a bulky backup copy eating up your disk space. It's a lightweight, nearly instant representation of your system at a specific point in time. It doesn't duplicate all your files. It simply references the existing data blocks. Only when something changes does new data get written. This means you can create snapshots in seconds, and they consume minimal storage at least initially. It's like freezing your entire operating system in a perfectly preserved state, ready to be restored at any moment. Think about what this means practically. Before a system update, you create a snapshot. After installing new software, you create another snapshot. Before experimenting with configuration files, kernel parameters, or new desktop tweaks, snapshot. If something breaks, rollback. It's like having an undo button for your entire operating system, not just a file, not just a folder, the entire system. And here's the shocking part. Many Linux distributions already support this. Some even integrate it directly. On distributions like OpenSUSE, snapshots are deeply integrated into the system using tools like Snapper. On Fedora, Btrfs is now the default file system. On Arch-based systems, tools like Timeshift can leverage Btrfs snapshots seamlessly. Ubuntu users can enable Btrfs during installation or convert existing setups. Yet despite this widespread availability, most users never activate its full potential. Let's paint a real-world scenario. You decide to install a new graphics driver. Maybe you're gaming. Maybe you're experimenting with Wayland. You run the update, reboot, and suddenly your display manager won't load. Black screen. Cursor blinking. Instead of searching forums for hours, you reboot, choose a snapshot from 2 hours ago, and your system is fully restored. That driver installation never happened. It's as if you stepped into a time machine and reversed the mistake. Now imagine taking this further. You're a developer testing risky dependencies. You're a content creator installing beta software. You're a power user tweaking system-level configs. Each experiment becomes safe, because every change can be reversed. Your system becomes fearless. This fundamentally changes your relationship with your computer. Most users operate cautiously. They hesitate before updating. They delay upgrades. They avoid experimentation because the risk feels too high, but with snapshots, risk disappears. Your Linux machine becomes a playground rather than a fragile glass sculpture. Another powerful aspect is protection against silent corruption and ransomware. While Linux isn't commonly targeted by ransomware in desktop environments, the threat landscape is always evolving. If malicious encryption ever touched your files, snapshots would allow you to restore clean versions instantly. Since snapshots preserve previous states, encrypted files wouldn't overwrite historical versions. That alone can be the difference between disaster and total recovery. And let's talk about system updates. Rolling release distributions are powerful, but sometimes intimidating. Arch Linux, for example, delivers bleeding-edge updates constantly. That's exciting, but occasionally updates conflict or introduce instability. With automated snapshotting before each package transaction, every update becomes safe. You gain cutting-edge software without the fear of breakage. This is where automation becomes game-changing. You don't even have to manually create snapshots. You can configure your system to generate them automatically before and after updates. That means every system upgrade is wrapped in a safety net. You wake up one day, run your package manager, and even if something goes wrong, your previous state is just one reboot away. Performance-wise, snapshots are surprisingly efficient. Because Btrfs uses copy-on writes, snapshots are metadata operations. Creating one takes seconds. Restoring one is equally fast. Compared to traditional full-disk imaging solutions, which require external drives and long restore times, this is instant system cloning at the file system level. But here's the deeper revolution. Snapshots change how you think about storage. Traditional file systems treat data as static and linear. Btrfs treats it as dynamic and versioned. It's like turning your entire OS into a Git repository. Every change is trackable. Every state is recoverable. Your system evolves, but its past is always preserved. And this extends beyond system files. You can snapshot your home directory separately. Imagine editing an important project, making changes you later regret, and simply rolling back your home snapshot. Or recovering a deleted configuration file without digging through backups. Snapshots make recovery effortless. There's also a psychological shift that happens when you embrace this feature. Instead of fearing updates, you welcome them. Instead of hesitating before installing new software, you explore. Instead of worrying about breaking your system, you push it further. Your Linux PC transforms from something you cautiously maintain into something you confidently command. Now let's address a common myth. Some people believe snapshots are the same as backups. They are not. Snapshots protect against software-level mistakes, not physical disk failure. If your drive dies, snapshots on that drive disappear. That's why combining snapshots with external backups creates an unstoppable strategy. Snapshots handle immediate recovery. Backups handle catastrophic loss. Together, they create resilience. Storage management is also smarter than you might think. Because snapshots share unchanged data blocks, they're space efficient. However, if you constantly modify large files, snapshots will accumulate unique blocks over time. This is why periodic cleanup policies are important. Tools allow you to automatically delete older snapshots while keeping recent ones. You get the benefit of time travel without filling your disk. Another hidden advantage is system experimentation. Want to test a different desktop environment? Snapshot. Install KBE. Don't like it? Want to try a new window manager? Snapshot. Experiment. Rollback. Want to test a beta kernel? Snapshot. Boot. Rollback if unstable. It becomes addictive. Even major distribution upgrades become trivial. Instead of fearing the jump from one version to another, you snapshot your system, perform the upgrade, and if anything behaves strangely, you revert instantly. No reinstall, no data migration, no downtime. For content creators and YouTubers, this is revolutionary. Imagine demonstrating risky tweaks live on video without fear. If something fails, you restore instantly and keep recording. For developers, it means sandboxing at the file system level without virtual machines. For gamers, it means experimenting with drivers and performance tweaks safely. And here's something even more mind-blowing. Bootloader integration allows you to select snapshots directly from your boot menu. That means even if your main system won't boot, you can launch a previous working state without needing external media. Your system carries its own rescue environment built in. This hidden Linux feature isn't flashy. It doesn't have glowing RGB lights or a marketing campaign. It's quiet, structural, deeply integrated. But once enabled, it fundamentally alters the power dynamic between you and your machine. You stop being a user who reacts to problems. You become an operator who controls time. Imagine explaining this to someone stuck on another operating system. They update their computer and pray nothing breaks. They install new software and hope compatibility remains intact. They experiment cautiously because recovery is painful. Meanwhile, you update fearlessly because every action is reversible. And the beauty of Linux is choice. If Btrfs isn't your preference, there's also ZFS, another advanced file system with snapshot capabilities. Linux doesn't lock you into one model. It empowers you with options. But Btrfs hits a sweet spot for desktop users. It's integrated, efficient, and increasingly default. Many modern distributions quietly move toward it without loudly advertising its potential. The feature is there, waiting. The biggest tragedy is that so many Linux users never flip the switch. They install their distro with default settings, unaware that selecting Btrfs during installation unlocks an entirely new paradigm. Or they use Btrfs but never configure snapshots. It's like owning a supercar and never leaving first gear. So what happens when you truly embrace it? Your PC stops feeling fragile. It feels invincible. You stop formatting and reinstalling annually. You stop fearing system decay. Your OS becomes something that can evolve indefinitely because every mistake is reversible. And that changes everything. It changes how long your installs last. It changes how confidently you tweak. It changes how you troubleshoot. It changes how you update. It changes how you learn. Because the safest environment to learn in is one where failure has no permanent consequence. Linux has always been about control, freedom, and transparency. Snapshots amplify all three. They give you control over time, freedom from fear, and transparent system states you can navigate at will. So if you've been using Linux without leveraging file system snapshots, you haven't truly unlocked its full potential. You've been driving a powerful machine with a hidden turbo button left untouched. Enable Btrfs snapshots. Configure automatic pre-update snapshots. Integrate them into your bootloader. Set retention policies. Experiment boldly. Once you experience the freedom of instant rollback, you'll never want to use a system without it again. And that's why this hidden Linux feature can change your PC forever, because it doesn't just add convenience. It transforms your relationship with your computer at a fundamental level. It replaces anxiety with confidence, replaces fragility with resilience, replaces caution with creativity. You're not just using Linux anymore. You're mastering it.